We're still not sure quite what we're seeing. Are we really seeing the earliest galaxies, or are we seeing some galaxies at later times that may be mimicking the images and spectra of these early galaxies?
Jupiter, as we've never seen it before. These unprecedented views of our solar system's biggest planet were revealed by James Webb, NASA's largest and most powerful space telescope. On the day the first images were released to the world in July, scientists and engineers had hoped, but few expected they would see so much in such revealing detail.
I realized sitting there in that 1 hour, I saw more science than I've probably ever seen in a week, month, even a year in my life was there in just those images.
Garth Illingworth is a distinguished Professor Emeritus of Astronomy and Astrophysics at the University of California. He was involved in the development of James Webb. He watched the launch on December 25, 2021 from the Space Telescope Institute in Baltimore, US, where the Mission Operations Center is located.
So we came back 6 months later to the auditorium again to see the release images, or 7 months later. And the room was totally packed. I think people were sort of cheering, clapping. The images would come up on a giant screen, and then there'd be a little discussion about it by somebody who knew the images and the background. And so people were incredibly enthusiastic about it.
I first met the professor a few months before the James Webb launch. In the 1980s, he worked on the Hubble Space Telescope. He then led the small group that developed the next generation space telescope concept that became James Webb.
The director of Space Telescope Science Institute in the 1980s was Riccardo Giacconi, who subsequently won a Nobel Prize. And I was his deputy director, and Riccardo came in one day and said to me, "You need to start thinking about the next telescope." And I said, "But we haven't even launched Hubble yet, and we're up to our eyeballs trying to get Hubble to fly and to be ready to go." And he said, "Trust me, you need to do this."
You've called space telescopes time machines. Why is that?
Telescopes are really time machines in a way because of the way light takes so much time to travel in the universe. The universe is huge, and we think of light as traveling instantaneously on Earth. But in fact, the light that we see from the sun actually left 8 minutes ago from our planets as we look at the probes which go past Jupiter and Saturn. That's more than an hour for that light to reach us, the signals to reach us from those planets. As we go out, the nearest star, the light takes 4 years. From the center of our galaxy, the light actually takes something like 26,000 years to reach us. So for the nearest galaxy, the Andromeda galaxy, a large galaxy like our own, the light left 2.5 million years ago. The universe itself is 13.7, 13.8 billion years old.
But how is it that light can travel over 13 billion years and yet it hasn't disappeared, it hasn't faded?
It's got incredibly faint. So that's why we put big telescopes in space and huge telescopes on the ground. It's billions of times fainter than we can see with our eyes. And so we really need Hubble and, of course, James Webb Space Telescope to explore that regime in time, back when the very first stars and galaxies were forming.
Now this $10 billion telescope is taking the images from its orbit at Lagrange Point 2, about 1.5 million kilometres from Earth. And the professor is going to explain to us just what it is we're looking at. Why did NASA decide to release these images first?
Well, it's because they look great. NASA's goal, of course, with the early release observations is to demonstrate that the telescope is working extremely well, that its instruments are working, and so they have taken examples of every one of those major capabilities to show that it works, but they also wanted to touch on the science.
Many of the images have been taken before by other telescopes, but not like James Webb. This new image of Neptune shows 7 of its moons and 4 of its rings. Images taken before by Hubble in visible wavelengths appear blue due to the methane gas in its atmosphere. But that methane absorbs James Webb's infrared light, so instead it appears white and glowing. Bright spots and streaks are methane ice clouds, which reflect sunlight before it's absorbed by methane gas. Scientifically, which image excites you the most?
The deep field one was the one that scientifically really relates to me the most. Seeing the first galaxies in the universe was a primary goal. And so this image actually is a reflection or is an example of how we'll be exploring that. In this image is really a history of the growth of galaxies through almost the whole life of the universe.
The light of thousands of newly discovered galaxies was too faint for previous telescopes to detect. James Webb is able to see the light because of its powerful technology and something called gravitational lensing. As light of distant galaxies passes by massive objects, the gravitational pull can distort or bend the light around them. Light from objects directly behind these galaxies follows the curve of space-time. So the light on our side of the lens is distorted, which is why some galaxies in the deep field image look blurred or stretched.
But the one that most struck me was the Carina Nebula. This is a region of our galaxy which is forming stars and planets. It's a star nursery, a planet nursery. And so the planets and stars are forming in this huge dust cloud. It's about 7,500 light years away, so a small fraction of the size of the galaxy, about a quarter the distance to the center of our galaxy roughly. And that image is about 15, 16 light years across, so it covers a big area actually. But what is so dramatic about it is that there's a mix of new bright stars at the top part of that, which are so hot and so powerful that they are eroding away the nebula at the bottom. And there's streaks of blue that you see there, that's hot gas and dust that's coming off the nebula as it's being eroded away by the hot radiation from these, the hot light from these stars. And then within that nebula, little regions are exposed where stars are forming and blowing out material. So there's just, while it's visually exciting, it's also scientifically amazingly complex and representative of so many stages of the formation of stars.
What can you tell us about the Cartwheel Galaxy?
This galaxy is about 500 million light years away, and it is really unusual. And when you look at that image, there are actually the Cartwheel Galaxy itself and some other little galaxies on the side. So it's sort of part of probably a group of galaxies. And that whole image is about a third of a million light years across. We often see that galaxies are merging and interacting, but this is a very unusual interaction. This galaxy, a little galaxy, came right through the center, and in doing so, it caused a shock to the whole of the other galaxy, the big spiral galaxy, and the gas formed a ring and all collided together and started to form stars. So that's what that bright outer ring is. And the inner ring is sort of a little result of this perturbation, this sort of change in the gravity. As one galaxy roared through the center, it also moved stars around in the center. And the galaxy that roared through the center is way out of this picture. So it's actually not here anymore.
James Webb is working in the infrared with a sensitivity, resolution and quality that has never been achieved by other space telescopes. This allows it to study the earliest star and galaxy formation. The universe is expanding, so the further back in time we look, the faster objects are moving away from us, redshifting the light. This means that light emitted as ultraviolet or visible light shifts more to redder wavelengths, into near and mid-infrared.
And this is where Webb excels, by opening up a new part of the spectrum, a new part of looking at the universe. So we have cameras that work at sort of near infrared, and then we can go out further in the infrared. But Webb also has instruments which spread the light out. The Europeans built one of the huge spectrographs for this telescope. And so the NearSpec was built in Europe as part of the European Space Agency contribution to Webb, and it's an amazing instrument. That is going to reveal so much. we have a Canadian instrument called emeritus. And that one is also a uniquely capable and very powerful instrument that can also spread the light out as well. So that's the Canadian contribution. And then the long wavelength camera, the MIRI instrument, was mostly built in Europe, and then with contributions on the US side, particularly for the detectors, for the actual part of the camera itself. And so this is very international consortium collaboration here that has contributed to Webb and actually contributed absolutely crucial components.
And the near-infrared camera on James Webb also revealed more information about Stefan's quintet, didn't it?
We now had, again, the nearer infrared camera and the long wavelength camera, and together they provide an amazing amount of information. And what is so spectacular about this image is that on this sort of upper right, there's two galaxies that are clearly colliding with each other. And so doing, stars and gas is torn out of each galaxy in these huge sweeping arcs. And what is happening in there, you can also see that there's a whole lot of stars that are forming now. As this gas is torn out, it also collides and forms new stars. So this is a dramatic example of what is a key process in building up galaxies from the early days. Galaxies collide, they can even stick together, and eventually will in this case, I think, too. But they also form a lot of stars when they do that. So it's a key step in building galaxies. But also what was revealed by Webb, which we hadn't known before, in the upper right galaxy, in the middle there's a giant black hole that is emitting a huge amount of light. It's just we couldn't see it before because it was all covered in dust. But I, just sitting there thinking, wow, folks will be working on this for ages with all this new information here.
While all expectations have been exceeded so far, there have been remarkably few moments of concern, although one in particular got a lot of attention. There's always a chance James Webb might be hit by something, so there must have been a sharp intake of breath when one of the mirrors was damaged.
Some tiny little particle coming in extremely fast whacked into one of the mirrors. Fortunately, one of them was not a major problem. It had a discernible impact. It changed the shape of that mirror a little bit, but we could go back in and we can correct the shape a little too. This is one of the beautiful things about this telescope. Amazing that we have control over each of these segments, tip, tilt, moving it up and down, but also changing the shape a little bit too, the curvature. So that was a wonderful decision to put that capability in there, and that has helped offset the damage from this micrometeorite. So we're actually still way better than we said that we were required to be. That telescope is still nearly twice as good resolution as we ever expected it would be. But if we get lots of these, it will ultimately degrade the telescope.
I guess it's just the universe reminding us of how tiny and insignificant we are.
Yeah, right. Well, exactly. Webb does that every day. One planet on, one star, but, amongst billions of stars in our galaxy, and there are billions of galaxies. So, we don't exactly rank high in the ratings here.
James Webb will continue to dazzle us with these images, while the experts, the astrophysicists, astronomers and the like, will continue to have their theories stretched and minds bent as the enormous amounts of data are poured over. It's already happening now.
We're still not sure quite what we're seeing. Are we really seeing the earliest galaxies? Or are we seeing some galaxies at later times that may be mimicking the images and spectra of these early galaxies? So it's a time of great uncertainty, but also great science and great interest in what could be revealed here about the earliest galaxies. There's no doubt Webb is going to rewrite the science textbooks about this time in the universe. The first billion years is going to be completely different in a year from now, and it already is different to what it was 3 weeks ago.